So in this video, I want to talk about units, and all the units that we use come from 7 units known as the SI base units, and each of these units is for one of these physical quantities. And so sometimes you'll hear people refer to these physical quantities as different dimensions. They both mean the same thing. And so let's just go through the units of these because these are really the building blocks of all the other units that we'll be using. So length is given by the meter, which is just an m. Whoops, that's kind of a bad bracket. Just m. For mass, we use the kilogram, which is given by kg. And you might wonder why we don't use the gram. After all, kilogram is 1,000 grams, so you might think it would make more sense to use the gram instead, but we actually end up using the kilogram as our SI base unit. For time, we use the second. Second, spelled with a C, and we denote that with an S. And I just use these brackets to show that these are units that we're talking about, not variables. For electric current, we use the ampere, and sometimes you'll hear people refer to it as amps. It's just the same thing, and we give that with a capital A. For temperature, we use Kelvin, which is just given by K. And you'll also see us sometimes use Celsius instead of Kelvin. The reason why is because Kelvin and Celsius have a linear relationship with each other. So if I increase the temperature by 2 Kelvin, that's the same thing as increasing the temperature by 2 Celsius. So even though Celsius isn't actually an SI base unit, we still often use Celsius in many of our calculations and when discussing temperature. For amount of a substance, that's just the mole, and its unit is literally just the word mole, just without the E. And so you might be wondering what we mean by a mole. How does that refer to an amount of a substance? Well, 1 mole is just 6.022 times 10 to the 23rd, and this is known as Avogadro's number, and 6.022 times 10 to the 23rd atoms. So that's just what we mean by 1 mole. We just mean this number of atoms of that substance. And for luminous intensity, we use candela, which is given by CD. And from these units, we also have what are called SI-derived units. And so SI-derived units are basically units that are just sort of built from these SI base units. So for an example, if we're talking about acceleration, for instance, the units of acceleration are meters per second squared, or meters per second per second. They both refer to this quantity. And so this, you'll see that this has meters in it and it has seconds in it. It's not just one of these base units, which is why we just refer to them as a derived unit. Another example is if you have a Newton, for instance. So a Newton is equal to kilogram times meters per second squared, and this just comes from Newton's second law of F equals ma, and you can put the vector quantities there if you want to be more formal about it. And so these are just SI derived units. They just come from these SI base units, but these base units are what we use to describe all of our other SI units as well as the quantities that I have listed here.